In this example, we are going to determine the exact value of the following trigonometric ratios. So first, we are going to find the cosine of 7 pi over 6. So maybe you remember from your unit circle that 7 pi over 6 is equal to 210 degrees. Okay, so maybe you'll remember that. You can refer back to your unit circle. Okay, or we can try and think of what 7 pi over 6 is in relation to our sketch. Because when we come back to it, our step 1 is always to draw where this angle will be on our Cartesian plane. Well, according to degrees, this would be 0 degrees, 9 degrees, this is 180, and this is 270. Right? So this 210 is between our 180 and 270, so we're probably living down here. Okay? But there's another way that we can think about this. Okay? We see that our denominator here is 6. Okay? So let's rewrite 2 pi and pi as something with a denominator of 6. We don't care about the 2 pi, or the pi over 2, or the 3 pi over 2, because we don't connect anything to the y-axis, we only connect it to the x-axis. That's why we're only going to rewrite the 2 pi and the pi, okay? Because those are the only two that matter to us right now. So, if we write 2 pi as something with a denominator of 6, well, it would have to reduce down to 2 pi, right? So I could rewrite 2 pi as 12 pi over 6, because that would reduce to 2 pi, but now I have my matching denominator of 6. Well, what about pi? How could I rewrite that? Well, if it had to reduce to pi, but I want to have a denominator of 6, that could be 6 pi over 6. And if we rewrite it this way, it's a little bit more clear what we're close to, because we have to look at 7 pi over 6. Well, that's closest to 6 pi over 6. And since it's 7 pi, it's just a little bit more than 6 pi over 6. So we can write it that way. 7 pi over 6 is equal to 6 pi over 6 plus, well, plus what? We need one more pi over 6. So that going to be my little ratio, and if it's 6 pi plus, that means I'm going to be down here. So let's draw it out. I'm going to be living down here like that. And the angle inside here, we've just figured out, is pi over 6. Awesome. That was my step 1. Now, step 2. I connect and label. So I'm going to connect my arm here to the x-axis to make a triangle. Triangle that up. And now I'm going to label the sides of this special triangle. So which special triangle are we using? Okay. Well, this is pi over 6. That means this is going to be a 1, 2, root 3 triangle. Well, this is always going to be 2. My smallest angle will yield the smallest side length that's opposite to it. So smallest angle is opposite the smallest side length, which leaves this to be root 3. But one thing we have to be very, very careful of here, okay, is now I'm dealing with this quadrant down here. And we have to remember, what's the only trig ratio that's positive down here? Well, it would have been tan. And that's because we have some of our side lengths here that are going to be negative. So in the x component here, okay, this is the negative side of the x's. So that means this is going to be a negative root 3. Well, what about this 1? It's on the y component. And y down here would be negative. So this is also going to be a negative 1. So it's very careful. Be very careful to watch those negatives. Now, you might be asking, well, why is this positive? One thing we have to remember is that this is actually our radius, right? And if we're thinking about a radius of a circle, we can never have a negative radius. Also, to figure out what that was, remember, it was r is equal to the square root of x squared plus y squared. We figured that out from our special triangles last year. Well, this will never yield a negative number because even though if we square our y, right, this is our y, and that's our x, even if we square a negative number, it will become positive. And finally, when we square root something, it has to end up being a positive. So the r value is always going to be positive. So you can make a little note about that if you want, but the r value was always positive no matter what. It's only the x's and y's that might be negative. Okay, so step 2 I have labeled, and finally, step 3 is my answer, or the ratio that they've asked for. So I've already filled in my x, y, and r, but they want the cosine. So let's just remember that cosine of theta is x over r. Well, that means for me, cos of 7 pi over 6 is equal to my x, which is negative root 3, over my r, which is 2. And there we are. That is my final answer. Cos 7 pi over 6 is negative root 3 over 2. Okay? So, and if you really want to check that, you can do this on your calculator, and I'll bet you will get the matching answer here. Okay? So, let's do another one. Okay? We'll do it out right here. Make sure we separate that. Over here, we are going to find the tangent, the tan of 7 pi over 4. All right, well, let's rewrite both of these with a denominator of 4, just like we did here. Okay. Well, to rewrite 2 pi as something with a denominator of 4, that would be equal to 8 pi over 4, because that just reduces to 2 pi, right? And now we have the same denominator on the bottom. Well, what about pi over here? That would be 4 pi over 4. All right. So if we want to know about 7 pi over 4, what do you think? Is it closer to 4 pi over 4, or is it closer to 8 pi over 4? Well, if you said 8 pi over 4, you'd be right. Because, take a look. 7 pi over 4 is equal to 8 pi over 4. But we have to take away 1. We are 1 less than 8 pi over 4. So we have to take away 1 pi over 4 to get that 7 pi over 4. So that right here is my little angle. And if we are 8 pi minus, that means we're living in here. So let's draw that out. That is my first step. I draw out my angle. So it's going to be 8 pi minus, so I'm living in here. Can be about like that. And the angle that's going to be inside here is going to be pi over 4. Awesome. Now on to my step 2. I will connect and label. I connect the end to my closest x-axis only the x, never the y, to make my little triangle. And now I label my sides. Well, if this is a pi over 4, you might remember that pi over 4 is the same as 45 degrees. And if it's 45 degrees, that means I'm using a 1, 1, root 2 triangle. Or I've got 1, 1, root 2. You'll notice that the 2's are always on the radius, whether it's a whole number 2 or a root 2. The 2's are always on the hypotenuse or the radius. Okay? But let's not forget about any negatives. So here for my x component, right, that is the positive side of the x's, so that's okay there. But what about my y component? This is in the negative side of my y. That's going to be a negative 1 right there. All right, so I've drawn out my angle. I've labeled my special triangle. Now my final step 3 is to answer what they've asked. Well, what are they asking for? They're asking for tan. Well, tan of theta is equal to y over x, right? My rise over my run. So for me here, specifically, when I have tan of 7 pi over 4, that will equal, well, what's my y here? Okay, well, this is my y, that's my r, and that's my x. So my y is negative 1. My x is positive 1. Well, I can simplify that, can't I? Negative 1 divided by 1. It's a tough one, but I think you can manage. It is negative 1. So again, if you'd like to double check this on your calculator, if you plug in tan, don't forget your brackets, and do 7 pi divided by 4, equals up that bracket, I bet on your calculator, in radians mode, it will equal negative 1.